Hi everyone, I got this trigo function questions whereby we need to first sketch and then we have to use the one that we have just sketched to solve the equation, which is this. Because of the keyword hence, that means what we need is to use what we have just sketched to solve part B. Now, so let's look at this function given, y equals to 1 minus modulus 2 cos 2x. We have to sketch from 0 to 2 pi. Now, let's analyze the equation given over here. Over here, we have, okay, let me just enlarge it. We have, okay, we have two terms, one here and one with the variable x. So x is the one that we need to sketch. Yeah, it's our manipulator variables, and the y will show the amplitude of the trigo function. So let's start with the cos, the basic graph of cos, which is cos x. Yeah? Now, let's recall, how do we sketch cos x? The basic graph for cos x for one cycle, that will be, it will go through 4 quadrants. Okay, 0, and then 90 degree, which is pi over 2, 180, which is pi, and then 270, which is 3 pi over 2. So these are the standard 4 quadrants that our cos graph will go through. Then cos graph will always start with maximum value, and the maximum value is the amplitude is actually 1 and -1. So we start with maximum, 0, minimum, 0, and back to maximum. So the standard graph for cos x, it will be like this. So this is called one cycle in 2 pi. All right. So when you see cos 2x, it actually means we have to complete 2 cycles in 2 pi. That means instead of seeing one of this, we shall draw double of this. Okay, now let's just figure out. These 2 cycles must be completed in 2 pi. That means every 1 cycle will be in 1 pi. So don't worry about that. We just carry out this same way like how we sketch the cos graph by plotting our 4 quadrants and also our maximum and minimum value. Okay, so maximum 0. Okay, let me just draw this. Easier for us to plot later. Okay, so maximum 0, and then minimum bounce back 0, bounce back to maximum. Now I use dotted line to sketch first because this is not our final graph. There will be more transformation later. So this is just draw. And then this is only 1 cycle. We shall repeat for another cycle. So just draw another 4 quadrants. Okay, maximum 0, minimum, back to 0, and back to maximum. So let's complete the graph. Another cycle of cos x. Okay. Now, so this one will be in 2 pi. So we just count how many quadrants, and half of it will be pi, and pi over 2. So we just label the important angle, which is the 90, 180, 270, and 360. The rest, no need to label. Now, I'm still using the dotted line because this is not my final graph. This is only y equals to cos 2x. Now, let's look at the function given. We are drawing 2 cos 2x, not 1 cos 2x. So what do? Shall I just stretch? No need. Just change the amplitude here, 2 and -2, instead of writing 1 and -1. And immediately we got 2 cos 2x over here. Then after that, okay, let's move outwards. You see the modulus? Yeah, look at the modulus here. So we start from cos x and then change to cos 2x. And then transformation and change our amplitude to 2. And then now we are handling the modulus part. So the modulus means whatever negative part will become positive. That means whatever at the bottom, negative portion, will be reflected upwards in the x-axis. So instead of -2, it becomes +2. And then, okay, let me use different color. I use red, okay, to get the new graph. Okay, so this will be our modulus 2 cos 2x. Okay, so this will be y equals to modulus 2 cos 2x. But we're not done yet. What we want is negative. Can you see the negative there? Negative here. That means all the numbers in positive after multiplying with negative, everything will change negative. That means the whole graph again reflects in the x-axis. So let's change to blue. Okay, so now everything will be reflected downwards. So it will be this one. Okay, this is still not the final graph. So we are still using the dotted line. Okay. All right, so this is y equals to negative modulus 2 cos 2x. Now, of course, you can skip from the red color straight away to blue color if you're fast enough. I just show step by step. Yeah? Okay, you can skip if you find that you are able to do so. Now, next, once we have done with the negative part, now let's look at the one here. The one means the y shift. That means the whole graph will shift upwards by 1 unit because +1. So instead of -2 here, it will now need to be shifted upwards to -1. And wherever the 0 value will be shifted upwards to 1 unit upwards. Yeah? So from here, let's just plot down all the important points on the green line. So the important points are the maximum and the 0 and the minimum. In this case, no more minimum. I mean, in terms of the graph, because I already modulus it. So we just concentrate on the maximum and the 0. Okay, and then from the blue graph, we shall shift everything to the green part. Okay, sketch nicely. You will notice that our amplitude is still 2. Yeah, amplitude never change. Okay, so this one, the green one, will be y equals to 1 minus modulus 2 cos 2x. Isn't it? This is the graph that we want. So let's draw with solid line. Should have drawn a solid line. Okay. Now, even though it's sketching, when you are drawing with pencil, no pen, yeah? Make sure the line are smooth line, no hairy line, even though they say sketch. Okay? Got to be a smooth graph. So the green one will be our answer. So next part, got to solve this equation. Now how? Let's write that equation first. So we have 2 minus x over 2 pi equals to 2 cos 2x. Now our objective is to use the graph that we sketch, which is y equals to 1 minus 2 cos 2x in solving this equation. So we only see 2 cos 2x. So what I want is 1 minus 2 cos 2x. So what can I do? I can just move this one over here. So the modulus 2 cos 2x will become minus. So now I will have 2 minus modulus 2 cos 2x equals to, bring this x over 2 pi to the right hand side. We will have positive x over 2 pi. And next, I only want 1 minus 2 cos 2x, not 2 minus. So what do? We minus 1 on the left hand side, and we minus 1 on the right hand side. Readjust the equation. So now we will have 1 minus modulus 2 cos 2x on the left hand side, and x over 2 pi minus 1 on the right hand side. And this one is actually the y. So what we need to is to draw the straight line x over 2 pi minus 1. So we need to show this because they say using the same axis, sketch the suitable graph. What does it mean by suitable graph? We have to work out till we get the straight line. It's always the straight line. Now, how do we sketch this straight line? Well, you can use the plotting method. Put x here, y here. Now, our x, we just put the pi, 0, pi, and 2 pi. So let's put 0. When x is 0, the y will become negative 1. When x is 2 pi, so replace x with 2 pi here. So 2 pi over 2 pi is 1. 1 minus 1 gets 0. So when x is 2 pi, y is 0. So plot this 2 points, 0, negative 1, which is here. And then 2 pi 0, which is here. Okay, use ruler and join this. Got to use ruler, yeah? Now let's say, okay, I don't quite like to use the ruler over here because it slows me down. But anyway, have to, no choice. Otherwise, I'm not able to draw a very straight line. Okay, so this is, okay, so let me just draw this. Okay, and label this as y equals to x over 2 pi minus 1. Now, when you answer the question, all this, you can just erase it. We just leave the final labeling. Now, the rest of the dotted line graph, just leave it there, okay? As long as you draw it light, with a very light pencil trace, and then your final answer, which is the green graph, is seen clearly. Of course, in exam, you cannot use green colored. You just need to use pencil, darken your line, that's all. Okay, so now we have to answer the question. The question is asking for state the number of solution. Okay, state the number of solution. So look at this graph. Okay, so they will meet here, all right? And one point here, another point here, another point here. All the intersecting point between the straight line and a green graph will be our answer. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So the number of solutions will be 8. That's it. Okay, so that is how we solve the question regarding to the trigo function. Okay, thank you so much. Hope it helps you. Yeah?